Thank you. Terima kasih. Selamat pagi. I ran out of my dictionary, so I need to switch to English now. So, yeah, thank you for nice introduction. I think it's a bit too long, but I think it's good. It's my pleasure to be here. I think this is my second time in last 6 months. Always enjoy coming here. It's a beautiful city. And I think in the earlier sessions, they introduced the topics. There is also coverage about a different field. So I thought in this session, I will give you a little bit of introduction to technology as it is, how this technology is transforming the research that we see currently, and what it was before, and where it is going, right? So I may not go into detail, but I hope I will give you some understanding about what Orbitrap mass spectrometry it is, and how it has transformed the research globally. So I start with this quote, right? The science is rarely limited by ideas, but ability to realize them. So this quote, probably if you are familiar with this picture, anybody who is a fan of Star Trek movie, I think they know what I'm referring to. And anybody can identify what is this device is? Yeah. The device name is called tricorder, right? Why I like about this is this movie is very old, right? We are looking at few 20, 30 years old, but they had the imagination about such devices, right? So what they imagine that this is a tricorder device which can detect things in outside atmosphere, it can diagnose disease, it can do many things very instantaneously, rapidly, and in the movie they demonstrated that it is very precise and accurate, right? Although in reality we are very far from having such device. But if we want to have something like this tricorder device, if I look at what we need for some characteristics, right? So it has to be a small footprint, right? We need to be a portable. It should be able to do very rapid analysis, gives you very accurate and precise result. At the same time, it should also be powerful to tell you something that you don't know, right? We were talking about unknown analysis. Earlier, I think Ms. Anjar described about non-targeted workflow, right? So we also want to identify something that is we are not aware in the sample. As I mentioned, we don't have any such device available, but I believe a mass spectrometry is a tool in future which could lead to this. It has most of the characteristics, right? You know, it gives you a rapid analysis. It is very accurate and precise these days. It is very powerful to identify unknown. The only thing that requires improvement is the size, right? It's not a portable yet. Having said that, we are continuously improving so that we are making it smaller and faster, which I will show in a while. Why I believe mass spectrometry is a tool? Because I think there are very diverse applications. I think some of the applications were already covered, and maybe something will be covered later on. So there is no as such limit to me what mass spectrometer can do. It can do very in-depth discovery to routine work as well. And then moving on to today's topic about multi-omics, I think it was very well described by two speakers earlier. What I want to emphasize here that why people have interest in multi-omics, right? Previously, we were looking into a snapshot. The idea here is that we want to use multiple omics together, or in another word, multi-omics, to understand various cellular processes at different stages of life cycle. For example, if you look at this life cycle of butterfly, the genomic sequence or transcriptome doesn't change throughout the life cycle, right? We are looking at early stage, pupa stage, or even butterfly, the genome remains the same. What is changes? The phenotypic characteristics, and how they are changing because of unique production or secretion of proteins which are leading to differential metabolism and so on. So what I want to convey here is that people want to use multi-omics, combining different omics field to understand biological processes distinctively at each stage, right? How it affects a particular disease or how it affects particular biological process. With that, I'm going into a technology, as I already mentioned about mass spec, and I think earlier speaker also described various type of mass spectrometers available. To me, I call them as a, I call them a molecular weighing machine. We just measure elements, and there are two types of mass spectrometers. We call this one as a targeted one on the here. This is the targeted one where we get average mass. On the other side, this is more like microbalance. We get very precise and accurate mass measurement. And in terms of the technology, we have high resolution mass spec. We call this general terminology. Here we call LC-MS, triple quadrupole, tandem quadrupole. These are various terminology. And again, when we look at high resolution mass spectrometry, where we want to focus today, 3 or 4 different technologies, right? The Orbitrap, time of flight, magnetic sector, and FTICR. But if we look at the current state of technologies, more predominantly Orbitrap and time of flight are used. Magnetic sector are used, but very relatively lesser. And FTICR, I think, almost negligible these days, okay, because of the advancement in Orbitrap technology. What Orbitrap has enabled us to do a lot of great discoveries. So this is one example. In 2014, with Orbitrap as a technology, researchers were able to map out what we call as human proteome. Right? So there was first publication which we were able to map out almost 84% of proteins in a human body. And then subsequently, there was another paper which went beyond to identify 88% of the human proteome. And this is significant discovery because now we have very good understanding of different proteins that are present in human system. And by understanding the proteins at different stages, we can understand how disease is progress, how somebody gets the disease, how we can discover drugs to target that particular disease. So all related to this discovery. Right. And this was the machine that was used to do this mapping of human proteome. And you can see that time this is the first generation of Orbitrap, which looks very big in size, right? And then we continuously improve the technology to make it more accessible, more small footprint, and more powerful, right? And then this year actually is 25 years of since we introduced Orbitrap technology. So Alexander Makarov, who is the inventor of Orbitrap technology, he first talked about this concept in 1999, right? The ASMS, which is the world's largest mass spec conference. And since then, there are several different iterations, and now we have solutions to do small molecule, omics, antibody, biopharma, so whatever type of analysis you want to do, we have the workflows and ability to do so. And how this translates to impact in research, right? So this is again another example. Looking at impact of Orbitrap as a technology. And this is, we are only looking at Nature and Science publications. So when we look at the number of publications, so since the commercialization of the LTQ in 2010, we can see there is tremendous increase in publication. And if we compare relatively to other available technology, which is time of flight, and probably those who have used mass spec, they know that there are 4 to 5 different suppliers for time of flight technology, and there is one supplier for Orbitrap. But if you look at the publication output, the number of publications utilizing the Orbitrap for high-end research is almost double than the time of flight technology. Why? Because the quality of the data that you get, the ability it provides you to do the research is uncomparable, right? So let's look at, okay, I won't go into detail, but this is just a snapshot of historical development, right? This was the first generation of Orbitrap in 2005. Then we have a Q Executive series in 2011. I think we have this instrument here, it BRIN, as well as few systems in Indonesia as well. And then we have Exploratory series. I think this is the instrument you will see when you visit Corpora Science Laboratory, which is our modern system. And I will talk about the evolution of that system and so on. But recently, we also introduced last year another cutting edge technology where we combine multiple mass analyzer into one. I'll have 2-3 slides later to talk about this instrument called Orbitrap Astra. So I think I talk about Orbitrap a lot, and earlier speaker also mentioned about Orbitrap, so I have one slide to explain how this technology works. So as the name suggests, Orbitrap, right? This is a trapping kind of device. We have 2 outer electrodes and 1 central spindle electrode. So what we do when the ions comes into the mass spec or your analyte, we ionize them into a gaseous phase, and then they enter the mass spectrometer, and when they reaches these Orbitrap mass analyzer, we apply some voltage. This voltage would squeeze the ions inside this particular device. And then these ions would rotate around this central electrode into this circular motion. And when they rotate, they generate oscillation frequency, and then this frequency we can do a conversion into accurate mass to charge measurement or mass measurement, right? This is a simple explanation. Again, there is an equation which explains why it is so, but the actual device that does all this measurement is very small. As you can see here, if I put on my palm, it would be half of the size of my palm. Because the device is such a small, it offers unique strength as a technology. So if we compare this together with the other available technology as time of flight, so sorry, I think this schematic may be bit too detailed, but what I want to highlight that the actual measurement for Orbitrap is done using this small device, whereas time of flight is this huge device. So we are looking at 2 centimeter device versus 2 meter device, right? So if you have very long device, it is very sensitive to temperature fluctuation in the lab and environment, meaning you need to do very frequent mass calibration almost every day or every other day in order to get reliable data quality. Whereas for here, because the instrument is such a small, once you calibrate maybe for 2 weeks or even 3 weeks, you do not need to worry about, and you can get consistent, good quality data without having any problem. Okay. So I think this is my summary slide on the benefits of Orbitrap before I go into development. A lot of benefits. I think we can get very good resolution, we can get very good stability, we can analyze multiple compounds into a single analysis, right? Typically people have to do 2 types of analysis to analyze like acidic compound and then do another injection to analyze basic compound. But with Orbitrap, you can analyze all those compounds into a single injection, so you don't need to run multiple methods. Okay, and I think earlier there was a question about the quantitation. So Orbitrap is a true HRMS system which can do both quantitation and identification in the same system. It has ability to do quantitation like your triple quadrupole system as well as the discovery. Okay. So why high resolution or accurate mass is important? If you are doing discovery, you want to generate a chemical formula. So I just want to elaborate here is that the generation of chemical formula is highly dependent on your accuracy of mass measurement. If you measure it very tightly, like if you measure below 1 ppm, you will have a lesser number of possible formula. If you do not have very good mass measurement, as your mass accuracy value increases, the number of possible formulas increases, meaning for one compound, you might have 50 possible formula. So how you can narrow down which one is the correct formula? So the best way to do is that if you measure below 1 ppm, then you only have to deal with very few formula for accurate identification of the compound. Okay. Other thing is ability to resolve. So if you look at the compounds, there are so many compounds with very similar mass. Okay. So if you're doing unknown discovery in your sample, it's very difficult to differentiate one compound from another compound. So here we are looking at a group of two pesticide molecule which are very similar in mass. And what we can see from this, as we increase the mass resolution to 60,000 and 120,000 and 240,000, we are able to separate them very well, which you won't able to do so if you do not have such high resolving power. Another common misunderstanding is that high resolution is only required for identification. But if you want to do very accurate quantification, it is also important, because if you do not separate a compound with similar mass, when you do quantification, you are doing either overestimation or underestimation. So for example, here we are looking at this compound, NDMA, which is an impurity in pharmaceutical drugs, which has a very similar mass to this solvent called dimethylformamide, which is used in pharmaceutical preparation. So if you do not have sufficient mass resolution to separate these two compounds, if you quantify them, you will have overestimation of this impurity, because you will also combine the abundance of this particular compound. So what I am trying to say that with high resolution, you can even do a very accurate quantitation, okay, or very precise quantitation. Since I work for Thermo Fisher, I need to show this slide that we have a range of solutions to cater your need. But what I also want to elaborate here is that the complexity of metabolomics, lipidomics, sorry, it's auto advanced to the last slide. You can see, in order to do a comprehensive coverage, if you are just using liquid chromatography, is not good enough. Sometimes you have to use a gas chromatography to analyze volatile compound. Sometimes you have to use ion chromatography to analyze very polar or ionic compound. The good thing is that Orbitrap can be used with GC, can be used with ion chromatography, can be used with liquid chromatography. So if you want to cover very broad range of compounds, you can do so by coupling different separation modules on this thing. A lot of people are not familiar with coupling ion chromatography, but if you are dealing with very polar metabolites, I'll just have one example here. So typically people will use this helic chromatography, which is a particular chromatographic method for very polar compounds. But the challenge with helic method is that you have very hard time to have a reproducible chromatography, because the equilibration time is very long. If you run the same method using ion chromatography, you can see the variability is very less. So if you use ion chromatography for polar compound, coupling with Orbitrap or other mass spectrometer, you have a better detection or analysis ability for polar metabolites. I mentioned about reducing the footprint. So this was our a previous generation of Orbitrap systems, and you can see a newer generation of system. What we have done, we have reduced the footprint. We have made it much smaller. So this is a true benchtop system. At the same time, we have improved the performance of the system. So you will see this system later in when you do a lab visit this afternoon. And why this is important? Okay, so I think I will skip this slide. Yeah. How we managed to do so? So as I mentioned, the key component of the Orbitrap is this device. So this is our first generation of device, which was like this. You can see here. And then from standard Orbitrap, we moved to high field, and now we are in a generation of ultra high field device. So what do I mean by ultra high field device? We make device very smaller so that we can apply very high voltage, and we can also we can also use very rapid scanning, okay? So what does it mean? By making it smaller, we reduce the vacuum requirement of the system. So we can make the instrument smaller. At the same time, we can also make it faster. So let's look at how fast it is. So again, if you have not used the mass spec, I apologize, maybe this data bit complicated, but what we are looking at is, this is our previous generation of instrument called Q Executive, and this is our current generation of model. So with previous system, in 1 second time, we are able to collect 1 full scan MS and maybe 10 MS data points. But with the current system, as you can see here, we are able to collect 3 to 4 MS1 data, and now we are able to cover 14 MS data points. What I mean, trying to say that the newer instrument can collect data 2 to 3 times faster than the previous instrument, meaning you can have a rapid analysis, you can give more information from the same sample using this data set. Okay, I think I'll this part. Okay, let's see. I realize working over the years that people think that high resolution mass spectrometry is very difficult to use, right? So over the years, we also want to make it more user friendly. So what we have done with newer series of the instrument, now we have predefined method templates. So depending on what applications you want to do, if you click on that application, we have a predefined method template so that you can just load. It will automatically load your mass spec conditions, so you don't need to worry about setting up the parameter in the mass spectrometer. Okay.
Excuse me, Mr. Dhaval, we have 5 minutes left. Okay.
Okay.
Sorry.
So, yeah. So I think those people who do small molecule analysis, right? This. Okay. Sorry. Yeah. Here. Sorry. They struggle to analyze something below mass to charge 50. This newer series of Orbitrap allows you to calibrate up to 40 mass to charge ratio, so even small labile molecule you will be able to analyze them. Okay, so I think I will skip this part, but I want to show you some applications. Okay, so probably, yeah. With the newer series of instrument, now as I mentioned, we can do both simultaneous discovery and quantitation. So in the same analysis, if you run your pure standard, we can do quantitation. At the same time, we can also do unknown identification, and this workflow we call as simultaneous quantitation and discovery analysis workflow. Okay, and let me show you some of the applications where some of our customers have pushed the limit. So let's say you can see this example where with our exploratory series, they were able to analyze 900 pesticides plus endogenous metabolites simultaneously from the same analysis. So again, it gives you the power to push the limit as far as you can, right? I did not talk about the multiplexing, but the Orbitrap also has a function to trap multiple analytes at a given time. So this is a method where we can do mycotoxin analysis in 1 minute. At the same time, it is meeting the minimum residue requirement based on regulatory guidelines. So you can do 1 minute analysis for mycotoxin. I think a lot of people work here on natural products and traditional medicine. And then there is this GNPS search engine where people want to compare their data with other people's data. So Orbitrap data is very well compatible with this platform. In fact, most of the spectrum available in GNPS is using Orbitrap as an acquisition instrument. Something very interesting, just I think 2 months ago, this was the publication where they use Orbitrap in this terminology called GeoMS, where they are using a mass spectrometry combining with geoarchaeology. So if you, maybe later you can Google this Denisovans, right? So these are one of the very ancient human species. They were found in Asia, Middle East, and the cave in Siberia. So what they did using Orbitrap as a mass spectrometry, they were able to understand how evolution of this particular ancient human species occurred, right? So again, the applications are very limitless, and again trying to identify new RNA relation, right? So we have additional sort of instrument, but I think with interest of time, I think I will not talk about this instrument. What I want to tell you is that we have the ability to, so the instrument that I mentioned earlier, okay, maybe I use this slide, I think it's better. Okay, so I wanted to ask this question, but with interest of time, I will not ask, right? So this is primary school, maybe physics. If you have two batteries coupled to one lamp, and if you have two batteries and you arrange two lamps in a series, all the three lamps would have similar light intensity, right? So what I want to convey that if you combine more than one mass analyzer, simultaneously you can harness the power of multiple mass analyzer in one system. So this is what we have been doing with our higher end Orbitrap mass spectrometer, we call Tribrid, where we have Orbitrap, we have ion trap, and we have a quadrupole system into one, which can be used for very deep structural discovery and insight. Okay, so I think I can share some of this application later on, so I will not talk about this instrument, but let me summarize here. Because I realize maybe the later part could be too heavy in terms of technical things. So what I wanted to convey that as a technology instrument service provider, we continuously strive to develop new technology. I hope I show some example the evolution of Orbitrap from first generation to now a new generation of the Orbitrap experiment series. It gives you enough sensitivity to do targeted quantitation, but it gives you a lot of power to do a deep discovery without worrying about stability of your data. At the same time, we are also coming out with new tools combining Orbitrap with multiple mass analyzer to enable a very deep discovery as well. With that, thank you, and yeah, I'll be happy to take any questions you have. Yeah, thank you.
Thank you, Mr. Dhaval, for your presentation. And now it's time to invite your participations. If you have any question for Mr. Dhaval, please raise your hand. Bapak Ibu, baik, monggo.
Thank you for very nice presentation. I'm interested in searching small molecule from natural product, and if using the Orbitrap LC RMS, I think I have no doubt to know the exact mass from the compound. But if I have an issue about working with the isomers, probably in your side you saw about leucine and isolysine. Can Orbitrap mass spec distinguish between these two isomers, or especially the stereo isomer, and or we have to use the strong separation in LC to separate the isomer first, and then to determine the structure of the small molecule that have the isomer. Thank you.
Okay, thank you for the great question. And yes, is a very common problem for people who deal with plants or food as such. because the chemical space is such huge, there are a lot of isomeric compound, okay? So if you ask, if your, maybe first question, can we use accurate mass to differentiate isomers? The answer is no. There is no mass spectrometer, irrespective of mass resolution, you can't separate isomers with the same exact mass, because the mass spec works by separating ions based on their mass. If mass is the same, no matter whatever resolution you have, you can't separate, okay? So, but there is way to do isomer identification by looking at their MS data, but even for some of the isomer, the MS data would also look the same. So that's where people go beyond MS. We could do MS3. So I think that our tribrid instrument, which has the ability to do what we call MS3, MS4. So when you go to beyond MS2, MS3, we get unique diagnostic fragment ions which can be used to confirm the identity of isomer. So we have done some work using flavonoids, because flavonoids you can see there are a lot of possible isomeric compound. But not all isomers can even be analyzed using MS3. So mass spec as a technology has inherent limitation to analyze isomer. The way to do so, if you do a very good chromatographic separation, then mass spec can help you to identify, because mass spec is a detector, right? So it detects based on mass. So if you couple with powerful chromatographic separation, yeah, you can overcome the challenge of isomer separation. And those isomers that can be separated by mass spectrometry, you know, the limitation, you ask about stereoisomer. I think stereoisomer, even if we go to MS3, MS4 level, unlikely there will be difference in their fragmentation. So the best approach is to do chromatographic separation, right? Yeah. Or ultimate technique is to use NMR. I mean, to get unequivocal identification of the isomeric compound. There are some development I did not show. Maybe I just quickly, okay, sorry. Sorry, I want to go to very quickly to one slide. Here, sorry. Yeah. So we have the instrument. So people these days are using alternative fragmentation. So this instrument, our tribrid, at the back end, we can use UV as a source to do a fragmentation. So for some of the lipid species where they are differentiated by position of the double bond, we can use UV-based ionization and fragmentation to get unique diagnostic ions to differentiate lipid isomers. So there are multiple techniques available, but it can't work for all types of isomers like what you would do with the chromatography. Yeah. So I hope I have given some example how you can use mass spectrometry as a tool. Yeah. Thank you.